Okay, so over here, it's going to be a little bit different. We're going to have a phosphate. This little I actually can't recall what that little I is, so forgive me. But you always stick the I below if it's just a single phosphate group by itself. You're also going to have what we call nicotinamide adenine dinucleotide. Nicotinamide adenine dinucleotide. Say that 10 times. Okay, so this is going to change to NADH. So a hydrogen is being added to it. Okay, this is going to what we call reduce it. Okay, that's how acids are, and through these processes, it actually has to do with the lactic acid cycle, which we'll kind of briefly touch on at the very end here. So this gets the hydrogen added to it. So now you have an NADH. These are very, very important for the next segment, the citric acid cycle. And this is actually going to be one of the products that we're going to hit on at the very end. So after this is also going to be another two-way process. We're going to be changing to 3-phosphoglycerate. Now, before we went from ATP to ADP. Now we're going from ADB to ATP. And energy is the whole point of glycolysis. Okay, so now we have one here. Okay, before we were expending energy, it was what we would term an exothermic reaction. This is an endothermic reaction with the D. Okay, so we're creating energy here. We're also, after that, we're going to hit another reaction. Okay, this one is going to switch to 2-phosphoglycerate. Okay, now I'm actually, you know what I'm going to do? I'm going to just kind of write these all down here just so I've got it. And then I'll come back up with the enzymes. This is going to change to phosphoenol pyruvate. And then this, a one-way reaction, is going to be our final product, pyruvate. Okay? So this enzyme catalyzed this reaction. Okay, so from 1,3-bis-phosphoglycerate. Oh man, make sure you don't get confused on where these enzyme reactions are occurring. This one is going to be phosphoglycerate kinase. Okay, it's a kinase because we're still working with a phosphate group. Okay, so we're taking it, we're adding the phosphate group. We're taking the phosphate group from 1,3-bis-phosphoglycerate, and we're taking the phosphate that was on carbon 1, and we're adding it to adenosine diphosphate, making it adenosine triphosphate. Again, our form of energy currency. Okay, now here, this enzyme is going to be phosphoglycerate mutase. Phosphoglycerate mutase. Okay. Let's see. So this right here. Okay, we have that there. Phosphoglycerate mutase. This one right here is going to be enolase. Again, I encourage you to really look into these enzymes. These different types of names have different meanings with the things that they do. Pyruvate kinase. Again, we know that means there's going to be something occurring with the transfer of a phosphate group. And you would be correct right here. Okay, we're going to have this adenosine diphosphate is going to switch to adenosine triphosphate. And then pyruvate is going to be our final product. Okay, now remember this is occurring twice. Okay, so we have adenosine triphosphate here, 1, but it's going to be times 2. Okay, and this is going to be times 2. So that means there's going to be 4 total. Okay, so what are our final products of this? Okay, now this occurred twice. Okay, so products. Okay, now we know we have 2-pyruvate, 2-NADH, again, which is going to go into the citric acid cycle. And then we're going to have, we're also going to have 2 hydrogen. Now, those hydrogens, I didn't really explain this before because it's part of the stuff that's a little bit more in depth, but where those come from back here, when the phosphate groups are added, it actually kicks off a hydrogen group to form that attachment. Or excuse me, not a hydrogen group, but a hydrogen. Okay, so let's see, where was I? Okay, so 2 hydrogen, and then our ATP. Now, again, in the first process, we expended 2 ATP. Remember that? So we were negative. And then in this process, we create a total of 4 ATP. So while there is 4 ATP being created, we did expend 2. So we say that we have 4 ATP gross, but 2 ATP was netted. Now, of course, the net is the important one. This is just kind of a side note here. Just keeping in mind that 4 was created, but it's actually 2 that you'll actually be getting as a form of energy currency. Now, this pyruvate structure here, it's going to be a part of going into the citric acid cycle, which is eventually going to go to the electron transport chain where we're going to get a crazy amount of energy. It can also go into the lactic acid cycle. Remember, I had mentioned that briefly before when it gets hydrogen atoms added to it. And that's exactly what would happen. If there is oxygen present, we would go to the citric acid cycle. But if we are working without oxygen, an anaerobic exercise or some form of movement, these hydrogen atoms here that were expended are actually going to attach to the pyruvate, and that's going to change it to lactic acid, and it will go to the lactic acid cycle. There's a lot of different pathways that the body will utilize for tons of different conditions. The body is very well adaptable. It can do crazy, amazing things. It's a absolutely incredible instrument. And I'd really like to get into those as time goes on and just kind of give these brief but somewhat in-depth overviews so you guys can try and understand this. Hopefully study this. Again, I encourage you to really look into the enzymes. The process of what the enzymes are doing is incredible. Again, it's a lot more in depth, but it would be good. It takes some understanding as far as learning to read scientific articles. Some really good stuff. I hope you were able to learn with this, and I hope it kind of gives you some idea of the process that's occurring. I really appreciate you guys and for taking the time to watch this.